Hello, this is Jeremy, and what we're going to do in this video is we're going to go through the salary data that I used to make a histogram, and instead what we're going to do is make a stem and leaf plot. Now, the general idea with a stem and leaf plot is to take whatever number you might have, so say it's 125, and break it into two pieces. One piece is going to be called the stem, and another piece is going to be called the leaf. Usually what you want is the stem to be however many digits it takes to make the leaf one digit. So if I want the leaf to be one digit, then it'd probably be the 5 here, so I'd make the stem 12 and the leaf 5. And now you can see there's a lot of room for messing with numbers like this, so if I had 8.3, this could be my stem and this could be my leaf. And so in this case, the stem is the hundreds and the tens digit, and here it's just the ones digit. So it really depends on the setting which one you'll see. Now with this particular data, everything's 2 digits, so I can say that the stems will all be 1 digit and the leaves will all be 1 digit. And then what I want to do is I want to take a look and say, okay, what's the smallest I have? It's 24. The largest is 68. So my first step is going to be to go from 2, the smallest stem, up to 6, the largest stem, without breaking. Even if nowhere in my data is there a number in the 20s, for instance, I would still write down the 2. Even if there was no number in the 40s, for instance, I'd still write down the 4. It has to be consecutive. So I go 2, 3, 4, 5, and then 6. And then I'm going to put a line, and this is going to separate my stems from my leaves. Now each number, instead of being represented by both of its digits, will be represented only by its leaf. So 24 will be represented by 4 off to the right. And now there's 2 25s, so I'll represent those with a 5 and then a 5. There's 2 27s, so similarly, a 7 and a 7. And there's a 29, so it will be represented with a 9. So now I can see 1, 2, 3, 4, 5, 6 numbers represented in a slightly smaller format. And when I go to the 30s, which will all have a stem of 3, I'm going to do the exact same thing. So the leaves for the 30s will be 0 for the 30. And then we got 3 35s, so 1, 2, 3 35s, a 36, 2 38s, and a 39. Notice that what I did was I kept the numbers lined up. Now, a lot of times software or something like that will be doing this graph for you, and so that will be automatic. But when we make them by hand, we want to make sure the numbers line up because we don't want to squish this so that it looks like there's fewer 30s than there are. So I'm going to continue this process. For the 40s, there's 3 40s, so that's represented by 3 zeros. There's 3 45s, actually 4 45s, so that's going to be represented by 1, 2, 3, 4 5s. And then there's a 47, so that's represented with a 7. For the 50s, we got 2 52s. We got a 58 and a 59. And then finally, for the 60s, we got a 61, another 61, a 67, a 68, and 2 more 68s. So this would be a stem and leaf plot for this particular data set. Now you would label it, salary is a small company up here. But one thing you would want to do to make sure when people look at this that it's not a decimal or something like that, although that'd be strange for salaries, we'd want to put some kind of key. So I could do something like this so that people know what my stem values were. So when I go through this, I always start at the smallest and figure out what the stem would be, and the largest and figure out what the stem would be, and I count up no matter what, even if those values are skipped in my data set. And then I just align the leaves, and notice that the leaves are always in order. Now you can ask a lot of questions, and you can actually talk about a shape of a distribution. Since this is the same data set we made a histogram with, you may remember what that shape looked like. It didn't really fit any of the classic shapes. But if you tilt your head to the right, you can actually see that we have the idea of a distribution here. So you can have a skewed right distribution or even a skewed left distribution. And I could ask a lot of questions. For example, I could say, what was the most common salary paid? And you could look here and say, well, I'm looking for the most common leaf. And we can see here that I got 4 5s. So that would all represent 45. So 45,000 is the most common salary. I could say, what was the highest salary? And you look for the largest, and that'd be 68. So it'd be 68,000. So I can still get quite a bit of information from this graph. Unlike a histogram, the individual values aren't hidden, and I can still see the pattern. So it's really nice for smaller data sets.